Here we have a short video on just the value of a candle and a flame in teaching physics and chemistry concepts. Um, let's just start with the basic shape of a flame. You can see it's sort of rounded and has this pointed end. That's due to the thermal energy that's being released during the chemical reaction of combustion. Combustion is a chemical reaction between fuel, which is contained here in the candle, and air. As the air enters the chemical reaction, at the bottom of the candle we can see it's blue in color. And this is the region where oxygen is being heated. Right around the wick, there's a kind of a foggy, darker area. This is the point of combustion where the hydrocarbon fuel is actually interacting with the air and creating the point of combustion. That releases an enormous amount of thermal energy, which then heats the air and the gases which rise in the yellow flame, which is primarily waste products. It's yellow due to soot, and there's also water vapor and, of course, carbon dioxide and other waste gases in that. We can see the density changes. As you look at the glow around the candle, you can see it heating the air. This causes the air to become less dense and expand. Temperature of the flame is about 600 degrees, and that causes the air to rise quickly, creating the process of convection, where the waste products are pulled upward, and that draws air in at the base. As you can see, the bottom of the candle is rounded, and that's where the air is actually being drawn in by the process of convection. The other thing that most people don't realize is a wick is a phase changer. A candle's a rare case where we can see solid liquid here in the pool right by it, by the base of the, and then actually gas wax coming out of the wick. And that's that, and once again, that round area just above the blue. Wax is one of the few things that is in all three phases, solid, liquid, gas, at surface temperatures. Very few substances have fusion temperatures and vaporization temperatures that are close together, water being the other one. So you can see a candle in just a couple minutes of examination is rather neat. We can see the reactants at the bottom. The blue is the oxygen of the air interacting with the wax, gas wax, paraffin in this case, which is the fuel. And those are creating the products, sorry about the wind, which is the yellow area. And that's, of course, soot and CO2 and water vapor and a few other gases that are created. Paraffin's a very common fuel. It's a wax made with hydrocarbons mixed in, so it burns fairly cleanly. And a candle's a wonderful demonstration because you can get very close to it and examine it carefully. So it turns out candles are a rather wonderful demonstration of physics and chemistry.